Welcome. In this video I'm going to show you how you can perform a binomial test using Python, specifically in Jupyter Notebook, and I'm using Python version 3. I have a shorter video that only explains the basics and is actually using some libraries. The main formula for a binomial test is here. And in this video I'm going to skip over all of this. Actually, I will run it just so that I don't have any other issues. But here I'm using some libraries, and in this video I will be going over a fully naive approach, as I call it, and then we're actually simply going to build up that entire function ourselves. It's of course not optimized, which probably the Skippy version of the binomial test does, but just for pure theoretical knowledge. So the first thing is to create a function called factorial, and that is defined as actually taking a number, an integer, and then multiply it by one less, and then one less, and one less, and one less. So if I have, for example, 6 factorial, I do 6 times 5 times 4 times 3 times 2 times 1. So I can do that with a loop in Python. So here's my basic. I'm going to define my own function for this. So no packages, and I'm simply going to run a loop. And let's check. If I do my factorial 6, I get 720. And if I do 6 times 5 times 4 times 3 times 2, I also get 720. The next thing in that formula is this notation, which is actually the number of possible combinations for k items out of n. And that's actually can be calculated with math using n factorial. That's why I needed that factorial function, divided over k factorial times n minus k factorial. So I can now use my combination to get immediately this result. And here you can see I'm just using exactly that formula. To see if it actually worked, I do let's pick 3 over out of 8, and I get 56. Now finally, that cumulative probability function for the binomial test is actually that combinations, then multiplied with the probability of success raised to the power of the number of trials up to that point. And then this is actually the opposite, which is this should actually not be I, but should be 1 minus p. So let me immediately change that, because mistakes are annoying. Raised to the power of n minus I. So if we do that in our function, we simply get, well, I'm going to be using a significance of 0, that's the starting point, and then going up to that k, it's going to actually run that entire function or formula up there. So let's see how that works with our 46. K was 12, had 12 selected, times 2, and I get the exact same result as I had earlier. Note that I used the 12, not the 34, because I need to use the lower of the two. So you could put in something like an if function to prevent that. I'm multiplying it by 2 because I'm doing a two-sided test, which will actually only work if you have a probability of 0.5, or at least it becomes a lot more tricky if the probability of success isn't 0.5. You could therefore do that check, and there's actually in Python also a factorial function, and there's also a combinations function in itself, but I promised to do it fully naive, so I built all the in-between functions as well. And that's it. So I hope this was interesting for you.